Okay, Wendy's. Today our goal is I can find the surface area and volume of 3D objects. Okay, so we're working with 3D objects now. So 6.2, and the first object we're going to look at is the cylinder. Okay, now again, remember you do not need to memorize these formulas. That is fine. However, let's take a little bit closer look at it. Well, a cylinder we can see is made of a circle on the top and on the bottom, and then around goes another piece. Okay, so we're interested in the R, the radius, and the perpendicular height. Now, what we also need to look at is our net diagram. Now, the only time that I would open up or peel this shape apart is if I'm dealing with surface area. So surface area, you can see we have two circles, okay, and the area of a circle is pi r squared. So if you look at the formula, it says 2 pi r squared, and then it actually is just a rectangle. Now the rectangle consists of 2 pi r h. 2 pi r is actually the circumference of the circle multiplied by the height then. Okay, so you can see how they're related to each other. Volume, no big deal here, pi r squared h. Um, One thing that you've probably spent a little bit of time on in elementary school was the fact that if I have a regular shape, and this is a regular shape where I have a base, and when I go up, that base kind of goes up with it, so it doesn't change shape going up. The volume is always the area of the base multiplied by the height. Okay, so the volume always is that. Now, if I look at the next shape, which is the cone, this doesn't work for volume because you can see my base for the cone is a circle, but as I go up, it goes up to a point. So it's no longer a regular shape because they've changed it. Now, the volume comes in two different formulas. And on the formula sheet, you end up having both of these. And it doesn't matter which one you use, they both work. Okay, so it's just a matter of your preference if you like 1/3 times pi r squared h, or whether you want to go pi times r squared times h divided by 3. Works the same way. Now, when we talk about the net of a cone, actually, if we peeled it apart, again, we have a circle, which is pi r squared, and you can see that's here. Now, what we do here, however, is a little bit different. It's called pi r s. Now, if you look closer at the diagram for this one, you'll notice that there is the h, which we had also with the cylinder, and the R for the radius, but we also have an S, and S is the slant height. Okay, so it's very different. Now you should recognize between the H, the R, and the S a certain other shape, a two-dimensional shape, right angle triangle, which means when you're dealing with the cone, keep in the back of your mind, you may need to use Pythagorean theorem to help you solve things. Okay, so anytime you have a right angle triangle, that means that that's in play. The next shape that we're going to look at is called the square-based pyramid. So square base means that each one of these along the bottom, it's a square, so all of them are equal to each other. Again, if I look at this, we also have a perpendicular height. Okay, so there'd be a perpendicular height, so that's a right angle, H. And again, you have a slant height. Okay, it's very hard to actually draw that in a three-dimensional idea. Now, volume, no problem. It's the volume actually of a square base pyramid is 1/3 that of a cube. Okay, so a cube is base times base times base. Okay, in other words, length times width times height. All of them are equal to each other. Okay, so in here, what we do is 1/3 of the base squared times the height. So it's almost the same as length times width times height, except we have to take 1/3 of that. Now, surface area is where we come to a little bit of difference. Okay, you can see the bottom obviously is the base squared, right? because they're all equal to each other. But then each one of the sides, when we peel them, are actually triangles, and there's 4 triangles. Now the thing is with the triangle, it has a base, but then the height that we're talking here is actually that slant height. So in order to find the surface area of a square base pyramid, we need base squared, okay, so that's that here, plus 4 of 1/2 the base times the slant height, or if we actually bring in that 4 times 1/2 is 2. Okay, so that's where the surface area formula comes from. Okay, so as I said, you don't have to memorize those formulas, but it's good to understand where they come from. Now, the last one shape that we're looking at is the sphere. Now, the sphere has the formula 4/3 pi r squared, or again, if you prefer, 4 times pi times r squared divided by 3. No problem. Now, if I peeled open a sphere, it'd be like peeling open an orange, and you know that it comes out as a funny kind of shape. Its surface area is 4 pi r cubed. Now, the place that you would see a net diagram for a sphere would be things like geography, especially with maps. And they'll do that because the Earth is almost a sphere. So if you actually peeled it off, which is what our maps are like, it would be the net diagram for the shape, the sphere in math. Okay, so now let's look at some examples. Okay, some very straightforward examples first of all. Okay, and the first one asks us to determine the volume and surface area of the following. So again, nothing strange here. So the easiest one obviously probably would be the volume. Okay, so we would look up the volume. So we would look up the volume formula, and the volume formula is, and get this up here, and let's do purple, because I'm in a purple mood. So volume equals pi r squared times height. So pi, we're going to keep pi in our formula. Our radius here you can see is 4. We need to square that, and then we need to also multiply by the 9. Now it's not 9 times 4 and then squared. It's 4 squared. We have to watch our order of operations. Okay, and so then if we bring out our calculator and type all of that in, and I'll do it for this one just so you can see that I'm not cheating. So if I do pi, and remember scientific calculators have pi, times 4 squared, or 16, times 9, and we end up with 452 roughly, 0.4. So 452.4, and we're talking volume, so that's going to be meters cubed. Now, surface area, again, is not too bad because there's really only 2 dimensions we have to deal with when we're dealing with a cylinder. And if we go and look that up, it's 2 pi r squared, okay, so that's the bottoms and top, plus the circumference, 2 pi r times h. So again, it's a matter of substituting in our information that we know and then actually calculating. Now, if you have a really good calculator, you could probably get away with typing this whole line that I'm writing down into your calculator, which is fine, but you would have to show me the formula. You have to show me this. You have to show me the numbers that you put in. Whether you show me this line here, even though I recommend that you do it, I wouldn't take off marks if you didn't show me this particular line. So I'm actually have done the calculations, and so I end up adding these 2 numbers together, and I get 326.72, roughly 0.7, and this time I'm talking surface area, so it is squared. Okay? And moving right along, the next one is a cone. Now, a cone had a funny thing going on. Remember, we had a perpendicular height, we had a radius, but we also sometimes use the slant height. So the only time we use the slant height, if we go back and look at our formulas for the cylinder, sorry, for the cone, we can see that we use the slant height when we're finding surface area. So let's do the volume first, and then we'll look at that surface area. And I'm just kind of watching the time here. All right, so volume, again, other than writing down the formula, so volume equals 1/3 pi r squared h, which is 1/3. I'm using this formula, it doesn't matter, you can use the other one. The radius here is 5 squared, and we want the perpendicular height, which is 7. So again, I type all of this into my calculator. If I don't have a fraction button, I'm going to go 1 divided by 3, and then times the pi. So I end up with 183.3, and it's centimeters, and volume we're looking at cubed. Now, when we're looking at the surface area, if I write down the formula for the surface area, it says it's pi r squared, which is the bottom of the cone, plus pi r s. Now, we don't know s, so we have to calculate it. So it is a right angle triangle, so I'm going to take it out of the diagram. Okay, put my s here. This is 5, and this is 7. Okay, so there is our c value, and that's what we're finding. So we're doing c squared equals a squared plus b squared. In this case, it's s squared equals 7 squared plus 5 squared, or 49 plus 25, which equals for us 74. Okay, and then we take the square root of that, so our slant height is actually approximately 8.6. So now that we have that calculation, we can actually find the surface area. So let's see if we can get that done before we pause the video for the next part. So it's going to be pi, our radius is 5, again pi, 5, and our slant height we calculated it as 8.6. Again, after you do that, it's a matter of calculator job. So this is approximately 78.54, and this one is 135.09. Notice that I'm keeping 2 decimal places in my work, and then I'm finishing off with 1 decimal place. Okay, so we don't want to round like 3 or 4 times in one question. Okay, but at the same time, we don't want to have to put a million decimal places. Okay, surface area, so we're looking at squared. So I'm going to pause or stop the video, and the next one we'll have a couple more questions working, and then you're set to do some questions tomorrow.